Good second morning.
Are the blue sheets often going around the room? Back, please. There's a corporal punishment on chairs who don't return blue sheets. The famous Dr. Lee empathy, right?
Mike, would you please stop talking because Mike has to talk. You're on, buddy. This is second session. You're still in Bier. Thank you for coming back. You just want to shut the door back there. We're pretty late. Just that's an elevator corridor. There we go. Thank you very much.
Hello.
No, so I'm serious. Where are the blue sheets, guys?
Anyone see blue sheets? Right. In the corner. Excellent. Yeah, they said we've got 4 of them. Said, anyone not sign the blue? All right. Let's see who goes around.
Distribute, sign.
I don't know. We'll make it work. Can you do full screen or no? Do you know? Do you have the technical wherewithal to make it full screen? Is this PDF mode? Okay, we'll make it work. All right, so this, I think in the 15 years I've been coming to ITF, I think this is the first time I've ever not been rushed for a presentation. We have an hour, I think, so I'm just going to take my time and enjoy myself and maybe tell a few jokes. I've got some stories. I mean, I could keep going. So,
All right, request from Jabber is that we are like fooling around with the camera and the whole thing is shaking or some cables. So the request is to not do that.
oh, right over there. Just don't bump that.
Yeah.
Just don't bump that chair. Yeah. All right. So this is going to be a V6 hour. So this draft has spawned from a variety of drafts that have been presented over the last few years on V6. The problem being how to get Bier headers across a V6 core, whether that V6 core is on a data center or operator core or whatever that may be. That's the problem. And so last IETF, we presented one of our solutions, one of the many solutions that have been presented over the years. And in that discussion, it became pretty obvious that it would be best to pause for a bit and just have a draft that describes the problem that's trying to be solved, discuss some use cases, and mention the solutions that have been proposed up until now to help the working group to come to some sort of conclusion. Because a lot of people have been asking us, we've had customers asking us about Bier and V6. You've got the segment routing folks working on that, and they have asked, about Bier in that, SRv6 world and how we're going to make all that work. So our goal is really in this draft to be completely solution agnostic. We tried to be as unbiased as possible and just help the working group to determine what path that we want to go with IPv6 and Bier. So that's our goal. Yeah, go ahead. Yeah, next slide. So it's just to be super clear. We're just trying to get Bier headers across V6 environment, and there's a variety of ways that you can do that, and we mentioned that in the draft. I've mentioned some of these things and reasons why we want to do this. Discussions happening in spring. If you're not familiar with this area, this environment in V6 is called non-MPLS IPv6 networks. And there's been a variety of considerations to have V6 encapsulation for Bier, to have Bier native in the header, to have Bier in the payload, to not encapsulate it. There's pros and cons. We've tried to, in this draft, not mention pros and cons because it could be a little bit contentious, and I'm not sure if that's the right approach, but we've just tried to be, again, just mention the solutions and just say how it is.
Mike?
Yes.
Greg, Cisco, are you saying that Spring Working Group has got active drafts right now working on V6 encapsulation for Bier?
No, I'm not saying that. I'm just saying that SRv6 is something that's progressing in Spring, and whether or not Bier is used in that environment or not are things that have been discussed. So as far as the working group goes, the working group, not chattered, but chartered to work on, this working group has been chartered to work on Bier v6. And we've had drafts that have been with the name including 6-man, and we've just changed that to IPv6. So to Greg and Tony, this is, at the end of this presentation, I'm going to ask for a working group adoption request. So just a heads up on that. And if that does happen, either now or later or ever, then there's probably some coordination that you'll need to do with the 6-man working group and maybe other working groups, I'm not sure. But we're determined to help the working group understand the applicability of this area. Okay. All right, just to continue to beat a dead horse, this is the purpose of the draft, to describe the problem of transporting packets with Bier headers in a v6 environment and the way Bier will function in that kind of an environment. There's been several proposed solutions. We're going to cover those, and it's supposed to help the Bier working group. Okay, so we're going to start just briefly talking about each of the proposed solutions so far. First one that has been proposed is just using Bier Ethernet in v6. There is a ether type for Bier, and so you can certainly use that ether type for Bier to be transported in a IPv6 network by encapsulating that data payload within the Bier Ethernet header. This is the one area and the only area that we did add some commentary, because with that commentary, it helps justify some other solutions that have been proposed, some more native IPv6 solutions. And so we've made some comments in there that, there are some benefits of having a more native solution to take advantage of v6, network programmability and other things that an actual native solution will bring. But we wanted to make sure that people knew that this is certainly a solution that is available as well. Next one. Feel free to jump up if you have any.
I guess,
yeah.
Greg, again, Cisco, I'd like clarification, but what do you mean by native?
Native within, encapsulated within a v6 header. And I think that will be made more clear as we go through some of those solutions.
Okay, now we're at that. We've crossed a line here. We're talking encode and encap, and not just encap. Looking at this description right here.
That's right. That's right. So
this is not just encapsulation. This is encoding.
That's right. So in this case, and I think his name is Pfister, Pierre Pfister, is that how you say that name? Okay. So there was a draft a few years ago. I think ICE and somebody else was involved in this one. This was proposed to encode that bit string in the low order bits of the destination address of a v6 address, and then the unicast address is a usual unicast address, and information there is used to inform that there is a beer header here. So we include this in the draft. We, again, just take information out of that draft. We didn't make a pros or cons statement. We just mentioned that this is one particular solution that you can use. It's a pretty simple solution. It seems to be a good solution, but we didn't say whether we thought it was good or not. The payload is attached to the Bier v6 header, and the IPv6 protocol number is set to the type of the payload, and blah, blah, blah. Okay. The other one, and this is what's been presented before, and I'm involved in this draft. We'll talk about this one next if it makes sense to talk about. But you can also, within v6, you have extension headers. You have a hop-by-hop extension header or a destination option header. Optional headers that you can add to IPv6 to add additional functionality. And so this is one solution where you could add Bier option, which would be a new option to add to a destination option to allow that Bier header to be used in what I would refer to as a native IPv6 environment. And I can talk about this more in the next presentation with my more technology non-agnostic hat on. Next one. So you can also transport Bier as a v6 payload. There's proposals that, Sandy, is this one of these yours? One of these yours, okay, so very good. So it'd be good to have you think about maybe even getting involved in our draft if you're interested. But you can transport Bier as an IPv6 payload. So the Bier header and the payload is part of the IPv6 payload. There's benefits to doing that. That's just one additional option. Okay. And then, of course, you can also tunnel Bier in an IPv6 tunnel. It could be a generic IPv6 tunnel using GRE, and the Bier header plus the payload is the GRE payload if you're using GRE, and that Bier ether type can be used for the header to indicate that there's a Bier header in the payload. So these are the solutions that we've so far identified as potential solutions for this working group to evaluate. Again, we don't intend to choose one over the other unless that's what the working group thinks that we should do. We're just presenting the facts. This is the problem, and maybe in subsequent drafts, the working group can decide what we think is probably the best way forward. If you go to the next slide. So we did list some requirements, and this may or may not be appropriate in this draft, but there have been discussions on the list in the past about this. Back in 2016 is kind of where it was suggested that maybe there should be some sort of a v6 extension header solution. Eric Rosen, who I just heard is retired, so good for Eric. I'm excited for him, but we did quote him in the draft. He listed in one of the email threads some requirements that he thought were best. So we just put them in there as potential requirements for whatever the solution may be should be considered. He mentioned things like it shouldn't require a hop-by-hop modification of the destination address, shouldn't require the BFRs to inspect layer 4 and things like that. So, so that's it. Since then, Rajiv has made some comments, and he showed interest in joining us as a author of this draft. He's mentioned some good comments, so we're gonna do a new rev for next IETF. Comments, questions, concerns.
Jeffrey John Juniper. I also comment on the IPv6 native, because the Bier forwarding uses its own forwarding algorithm. By definition, it's not IPv6 native, no matter how you do it.
But-
Taking notes.
Okay, I mean, before we go through the round of like chewing oath, we went through those things, a lot of arguments have been made before we kind of reopen the whole thing. What is this draft supposed to be when it grows up, you think, Mike?
It's supposed to be a document that provides the working group with enough information to describe this problem to know how to best provide a recommended solution to the community.
So, requirements document.
Yeah.
Maybe so. Maybe
Rajiv Asadi, Cisco, and that was a comment I wanted to make actually, which I've shared with Mike earlier, that this draft should really capture requirements and any additional relevant use cases that come out because of IPv6. But the focus should be on requirements and consideration.
Hi, Cisco. So thanks for putting that together. Actually, I do think it's useful to see all the different options, in a single draft, so you can have a quick overview on how to compare them. So that's good. I think the overall problem that we want to solve is we want to have a V6 packet replicated using Bier, right, and get to the V6 destination. Now, as you say, there are many ways how to do that, but and I came to the same conclusion as Jeffrey. Ultimately, the replication that you're doing is done through Bier forwarding. So no matter where you stick it, right, where you put the bits, ultimately you will end up somewhere where you do the Bier logic. So, and then it is a question like, so what is native, what is not? So how do you get the packet across from node to node? Because I think taking the different ether encapsulation, I think that's probably very clean. But I know people will say, perception, oh, but that's not IPv6, right? So if you then put a V6 address in front and you make this V6 address special to say, oh, now you're doing V6, and then you punt it to your Bier replication path. Same thing, right? But there's a lot of perception.
Yeah, sure.
And that I think is the biggest problem with solving this.
Right. So either you take the V6 bytes and you stop using them as V6. So it's not V6. You just found the bytes. Or otherwise, you stick it somewhere into a V6, but then you have to take away the global address significance from V6 because otherwise you get in trouble, right? What you forward on, it can have basically just local significance.
So the only thing, so the draft that I'm on with Pierre,
Yeah.
that's probably the most native one of them all, because you don't change the encapsulation, and you might end up, if you reset all the bits, using an IPv6 address that the application can understand, right? But there are other issues with that draft.
Yeah, which is,
Yeah. My only response to that is that's a great point. And in fact, if this document proceeds, it would be helpful to have your input as to some of those points that we didn't address in that draft that you're on with Pierre.
Thomas Eckert, Huawei. I think it will be interesting to wait on the final outcome of the SRv6 architecture and encapsulation documents, because the ongoing review with requirements from 8200 on, whatever encapsulation, changes you can even do on path, I think would equally apply here for when we put the bits inside the string, right? Because whenever we're resetting bits, that might well be considered within 8200 as, a new IPv6 packet, right? And that requires then rewrite of the source and destination IPv6 address. That is at least the, current understanding of when you're actually trying to change, SRv6 extension headers, that entitles a new encapsulation, so source and destination address need to change. That's just the cost of doing business from a different perspective than what I said, right? If you want to be in a wonderful extension header or behind the IPv6 header, that's the cost you have to suck up. Otherwise, go below IPv6. That's my perspective.
Stig, so I agree about the discussion about whether this is native or not. If it's not IPv6 forwarding, then it's going to be not native. But I see some use cases where you might want to have, say, like a repair tunnel or like bypass non-Bier router. We want to do IP tunneling. So you might want to do IPv6 forwarding of a Bier packet just to reach or bypass a non-Bier router. Or you might somehow connect to Bier domains by tunneling, basically doing IPv6 tunneling.
Okay, thank you. We could add those as use cases. Rajiv also mentioned in an email about aggregation networks, I think, that you thought would be a useful use case. So thank you.
Jeffrey. To follow up on Stig's point, IPv6 tunneling of Bier packets, the tunneling itself is not Bier forwarding. It's just getting the packet from one Bier file to another one. Okay. And the other point I want to make is that if you are trying to get an IPv6 multicast packet across the Bier domain, I assume you do not want to change the IPv6 multicast destination address. So if you want to use IPv6 Bier encapsulation, that means you are going to, does that mean you need to burn another IPv6 header?
Yeah.
Right, okay, so and-
Can I address that directly, just so we just don't rehash this? This is Greg again, chair or Cisco. In his diagram, there's nothing about the payload. The payload should be irrelevant in this case. If it's a V6 at the edge or V4 at the edge, that's irrelevant to what the encap and the encode for the Bier domain should be. So I don't think that's even in the problem statement, is it?
I don't think.
Yeah.
No, it's not.
So this is not about what is in the payload at all. This is what is in the transport network and how do we get this payload across that transport network.
Okay. Anyway, in that particular use case, you need to get another Bier header. No, I mean the IPv6 header in there, and the MTU. Do we concern about MTU? Would you rather use those extra bytes for bitmap for bitstream?
And don't forget that, IPv6 fragmentation at this point in time is at least highly discouraged. Okay.
Rajiv, sorry, Cisco. So I'm trying really hard to not jump into solution mode and keep the focus on the problem statement. So the requirements and consideration that need to go in, right? Whether we do the bits in the last 64 bits of the V6 header or inside the Ethernet header or wherever that goes, that's the solution space. So I think as a working group, we should definitely pay more consideration and attention to the requirements. There was one slide later that says, here the list of couple of requirements. I think those are really good starting points. We should start to think more about what else is missing or what else is not right in there, right? So the requirements are more relevant and important in this case, at least.
That should have been the first view graph of the presentation, in fact, yeah.
Okay, so let me just respond to that. So that's a very good point. Excellent point. We took it from the tact of, like what Ice mentioned, is that there's so many different solutions. Let's kind of just do a brief summary of all of them, just summarize them. It's a lot easier to know where we stand. I think those should stay in the draft personally, but instead of them being the bulk of the draft, the requirements and other use cases should be the bulk of the draft.
All right, Tony took the shot through my shoulder. That wasn't right.
What's that?
I didn't suggest that slide should have been reordered. That was Tony's point.
Oh. Yeah. So I don't agree with Tony, but that's fine.
What I was saying was just
Torres, just
yeah.
name again. Just
Okay.
get notes.
Yeah. If I go these requirements, what I'd love to see as well. So I like the requirements, but what I mentioned is that you're basically they're kicking out specific solution approaches like IPv6 extension headers. Right? That's my best understanding.
But no, I mean, those things have to be argued out. There are by no means axioms that we accept and are given, right?
No, but
That's the point of the draft and
Exactly,
getting
right.
the work.
Yeah. I mean, but the question is if we just want to kind of do waterfall, waterfall process means we write all the wonderful requirements that we would like to see, then we make an RFC out of that, then we go back and figure out solutions, and there is no solution that fits all these wonderful requirements. So, or if we try to have a little bit more interactive discussion about that, that's only what I was.
I mean, the format is to be negotiated. We can do an interim and just, we put you in a room and suck out the air really slowly, right? And then we go and rehash. we rehash all the solutions, the pros and cons, right? And we come back with a requirement set and the suggested solution. Encapsulation went through the process. It was incredibly productive, right? Possible format. The other format is that we argue the waterfall, and other problems we just engage in free-for-all jiu-jitsu where everybody argues for his solution. I mean, none of that is a given, right? It's to be argued what we do.
Well, I think what would certainly help to understand the constraints of what we can do when we're using IPv6 extension header is basically to get whatever best consultation from Sixmin we can get on the matter.
right?
So this is Greg Cisco, but now we've crossed that line again that Jeffrey talked about, I alluded to a little bit, and it came up quite a bit before, and I talked about it when you first brought up that second use case. There's encap and there's encode. And at some point, you're crossing the line and blending the two. We have a Bier header that's well-defined. Ultimately, it gets pushed down into a hardware fib lookup, right? So if we're deconstructing a V6 header to reconstruct a Bier header to get back into Bier forwarding, it's not V6. We're not using V6 forwarding. Really, what we're trying to do is find the neighbor with an encap that works hop by hop. Now, as I said, ETH is clean, but if you can't get it in hardware, what can we do? I've heard discussions of using link local V6. I didn't see that in the list because it probably hasn't been documented yet. Just probably some. Was it? So I just want to make sure in our discussion that we know we're blurring that line, that encap is the problem. And now we're talking about using encap and encode.
But so, Charles Eckert again, how is what you're saying different from, let's say, SRv6, right? You also have an...
How much time do you have?
No, in terms of logically from it's not IPv6 anymore, right? So I think the same argument could be said about SRv6 when you get a SID and the SID says all type of local programming and stuff, might as well result in replication. We don't know, right? SID could do anything.
I disagree in that each of the extension headers has a use.
Right.
In Bier, we're using that for disinformation that has to be deconstructed and turned into something else. Yeah, you have to build the entire mask.
Right, but why couldn't that, I mean, sorry, I still don't see why, I mean, do we like the option of being an extension header or not, right? So if everybody already says, oh, we don't like extension header, that's fine, right? If we like extension header, we have to deal with the problems of 8200.
But this, yeah, good point. But this draft doesn't have anything to do with whether you like a solution or not. It's just.
Jeffrey, so Greg, you just mentioned the hardware thing. If I understand it correctly, and also understand the proposal correctly, no matter what you do, well, no matter what option you go with, you always require new hardware. No,
If you think about the Bier in 6, and I'm not like, tooting my own horn here, that you state on normal IPv6 forwarding, which however is only link local, so it cannot run away from you. And you get it one link across, and from there on, it's normal Bier forwarding, right? So,
okay. So the I think you're talking about getting the Bier packet from one BFR to the next one.
Right.
Right, but
That's encap.
okay. But to do the Bier forwarding, when you look at the bit string and then how decide how you replicate packet, that always require new hardware or programmable hardware.
well, we don't have BFRs without Bier hardware. I mean, that's assumed, right? We can do magic and now make V6 do Bier. Maybe we should think about it.
So yeah, I guess so. Yeah, no matter what you do, to do Bier forwarding to the replication, you need hardware.
You can just address that. But if you're doing it based on a Bier header, it's quite specific. Now we're trying to reconstruct the Bier header from components from a V6 header. So that's even a more unique case.
I mean, Rajiv Asari. So from IPv6 point of view, the last 64 bits could be used in many different manners. I mean, there are tons of different RFCs out there, drafts out there, usage out there in mobility space, for example. So it's, I mean, having something in the last 64 bits is not really far-fetched. But again, that delves into solution, very specific solution. But what made me start thinking about it, does that really result in a requirement or a consideration that needs to go in this specific document? And so far, I have not been able to come up with one.
Hi, Cisco. So maybe one more point about hardware support. So I guess if you have a hardware that supports Bier forwarding, then you have. If you have a hardware that supports Bier, then you're 99% there. But I think with Jeffrey, that if your layer 2 encap is still different, you still have to get support for that, right? So you cannot assume that if you support Bier that you can do anything you do here, right? So, but we're very close once you have Bier support. Now, another question maybe that we should ask to know whether we should put those bits is that I think with SRv6, one of those things is that the extensions, they can be actually put in place by the application. right? Because it's L3. That's maybe an advantage for putting it into an extension header. So from the application point of view. So maybe that's something we need to sort of list as requirements and see what we want to do there. But of course, for the router, it's a pain, right? Because the bits are so far into the packet, right? You have to read so much bits already before you can actually get to your Bier header. That's, I think, is a problem.
So Greg, it says could just operate as the foil there. The app could create the Bier header just as well as it could, couldn't it?
But I think then you probably require socket support, right, or root access.
No, it would just be
Because it's all what your kernel allows you to program. So there's
it depends on what the transport is from that point. I can create as if it's going over Ethernet, yes. If it's going link local v6, probably not. I can construct it. Yeah, it construct it as just payload effectively from the socket's perspective.
I think for you need raw sockets and you need root access in order to create those packets. So unless you have kernel support for Bier, then you can access the
Not from the
socket
application
data.
side. The application again is not doing Bier forwarding. It could just be creating the Bier header and moving it on to the next Bier router. You're not actually creating a Bier transport socket.
So Tony was mentioning link local. So is there one of the options where you just hop by hop to IPv6 link local and then what was listed here, right? So
Right, and I mean the Bier in 6. I mean, just how I circle towards that is because when you look at really low-end hardware, right, the Bier thing could be actually done in the control plane really slowly, because the V6 hardware always exists. But then you pump it up and you do the stuff slowly in the plane, and you do link local again, which, for example, for wireless routers is not an unthinkable option.
well, I was thinking that if we just have the standard Bier header as just the next protocol from IPv6, we're also not an IPv6 extension header, and all my paints of 8200, or many of them, will go out of the window. And I mean, obviously, we're having to rewrite the source and destination addresses because they're linked local, so that's the cost of
Authorship on Bier in 6 open. No, Sandy, did the draft expire? The Bier in 6? I think we were refreshing that.
Have you listed that? And then, of course, the question is a little bit the local end cap. Can we derive it already right now from all the IGP stuff that we have, or are we missing something?
I'm losing there. It's just if link local v6 address, you can use it as next hop and do all the stuff with it, just the normal way, right? And the protection next hop is, of course, not the link local, right? That's a global v6.
I'm just like, it's getting quiet. I see eyes turning. I see private conversations. Anything else to comment on the problem statement draft? So if I can summarize, it's gonna be tough. Hopefully notes are good. An actual requirements list to extract from this would be a good thing to work from. Does that sound like what we're kind of looking at? Okay. All right. And then from there, I guess each of the potential solutions, hopefully they're documented somewhere to reference, or you go into some detail to evaluate in the doc. There, like say, if the drafts are live, we can point to them, right? Either because I don't think that's what I was asking Tony before. I don't think the link local v6 solution has been documented anywhere. Does it? Duly ignored.
While you're looking that up, I do have a
I'm just
question.
curious. Yeah.
I do have a question before you go, Torlis. Is one of the questions that we batted around is, do we remain agnostic with our opinions on these solutions? We've done today, or do we try to put in some pros and cons, some benefits to these solutions in this draft? That's the question I would have. Do we change it from what we have? Yeah.
Can I answer that? I'm going to answer that just as a contributor, not as a chair. I think the document would be far more valuable if you help walk through that process. But as a group, we document it, right? So that's totally fair as a group document and a problem statement and evaluating the that's exactly what we should be publishing. That's what I think. Anyone else disagree with that? I mean, that kind of gives the paper some value, right? The document some use.
I think the document is valuable to track all the stuff, right? Obviously, if we're not doing waterfall, but in parallel we start phrasing opinions, right? Maybe at the end of the document, most people feel, oh yeah, we know that 4 out of 5 options are crappy now, but it's still valuable, I think, to have document the informational, right? We can stay neutral right now. Whether we'll stay through, the working group last call, we'll see. I just wanted to say, right, I love the link local, but from Anima, right, we did everything with link local. They're another bunch of problem coming to you, right? Because they can be the same addresses on multiple interfaces. So, and hardware never likes that, and so.
You have comments on this draft in particular? So there's a lot of good opinions here. I want to make sure that we take this to the list. We can go on the notes here that these are things that the entire group needs to contribute to, and maybe restructure with a problem statement we can thrash at first, and then with those lists of solutions, we can start hashing out pros and cons. And in Torres' case, I mean, you took kind of an extreme, like all these are trash. Not necessarily. We could look at trade-offs. For different use cases, where maybe things.
I'm just saying worst case, right? I should say we should be open-ended, right?
No, that'd be best case would be all of them are trash but one, right? We know exactly what to do.
Right.
If it's like, if like in this deployment, this would be better. In this one, now we got a kind of a gray area we're playing with. So I'm just saying we don't know until we get the stuff out.
The only bad thing about is that we can't give the authors the guarantee that the working group will like to stay neutral through the end. I think we'll have to make that up, right? So
Yeah, that's
No,
that's a
I
good
think it
point.
says specifically that we're not going to be neutral, that we're going to look at these cases and we'll make decisions of the trade-offs.
Okay, so my request to the chairs then is that all the solutions document, including the next one, is a moot point unless we have a draft like this to kickstart things. So my request would be to, with the comments that have been made, turning this into more of a requirements draft, adding Rajiv and anybody else that may want to join us. Is this a document that the working group wants to adopt?
All right, who's read the doc? Who think this is a doc we should adopt? Yeah, it's pretty solid support. Okay, let's show the room supported adoption, and we'll take that vote to the list.
You know what? I'm just on the fly. Senthal, are you here? Where are you? Do you want to do this? I mean, I'm kind of tired of talking. Let's. I was so ambitious to begin with, but how much time we got? Senthal, coming up. Let's spread the wealth.
We have 20 minutes.
We have 20 minutes. So that did take a while. Yeah. No, do you want to present this draft?
Yeah, I mean,
Come on, do it from there. Here.
sorry.
New guy, pack up the rotten tomatoes, okay?
Hey guys, Senthil, Huawei again. Let's get started. So in this draft, we have proposed another way to encode Bier header within the IPv6 header. Let's see. I think Jingrong and Mike has presented the solution. Couple of the past two ATF meetings. From there, we have renamed the draft and rearranged and updated sections to make it more readable. Remove the problem statement part from this draft and spawned a new draft, what Mike has just presented. From the technical side, we have removed the dependency on the SRH and used unicast IPv6 destination addresses for some special cases. So we'll see about that in detail further. And we have added some more details with respect to each field of the encapsulations and the forwarding procedures which need to be followed. So anyways, we'll look about those things, the detail further. Next slide, please. Yeah, here, what we see here is the proposed encapsulation. You can see that, the original packet is encapsulated with the outer IPv6 header. You can see that at the top is the native IPv6 header, followed by a destination options extension header. which carries the native, which carries the standard Bier header, which is defined by RFC 8296. So what we propose here is to carry the Bier header within as a Bier option TLV within the destination options extension header. So here the IPv6 destination address, what should be used as a destination address in the outer IPv6 header? We propose that could be a well-known multicast address, which could be reserved, by INA, and the source address could be a routable IPv6 unicast address. Normally, ingress routers, IPv6 prefix. So this is what it looks like. So you can see that the packet which is encapsulated with an IPv6 header which carries an Bier header, we call it as Bier v6 header from here on. So to make things easier for us to discuss.
Can I ask a clarification quickly, Tony? Is the destination multicast address, is this a link local scope?
Yeah. So basically, at current stage, we didn't talk about the scope. We
Right.
say that FF0X. So the scope could be anything, but we think realm scope is the good way to start. But yes, link local is also another way to go.
Well, no, I mean, it makes a huge difference, right? So, okay, so it's the discussion is open. That's how I read it. Okay.
I'll skip this one now. We'll go to the next one. Yeah. So forwarding procedures, normally, yes. Just we discussed before that, it's just about where we put the Bier header. But once you, decapsulate and get the Bier header, we follow the normal forwarding procedures as described by, RFC 8279. There's no change there. But yes, we also have the IPv6 header. So there are some IPv6 specific forwarding procedures that we are talking about here. Like I mentioned before, the source address must be a routable unicast IPv6 address. Normally BFIR IPv6 address. The BFIR prefix that we have advertised in the IGP. And the destination address is again Bier multicast address. What we propose here is this FF0X AB, or could be an unicast address in some special cases, which we would see shortly. Yeah, nodes which support Bier v6 can obtain the non-MPLS Bier header as we have seen before, but the nodes which don't support Bier header, I guess that's one of the reasons why we have selected the destination options extension header, and it's backward compatible node which doesn't support a specific extension header like Bier options header or specific Bier options can just forward the packet using the destination address without looking into the extension header. So here we explain, try to explain how the forwarding works. You can see that as the multicast packet enters the Bier domain, the ingress router, which is A here, encapsulates the inner packet with an outer IPv6 header carrying the Bier header in the destination options header. Here, normal case where you can see that the destination address is set to a multicast address, which is reserved and well known for Bier routers. So as the packet getting transmitted, the transit nodes can look up at the Bier header, forward the packets using the normal procedures that we used to follow for Bier MPLS. So that way there is no difference here. Yeah. Before going to the next slide, we'll take
Yeah, I think one of the interesting questions, which is why I mentioned Spring and segment routing, is the question whether you're allowed to change the bit string without calling the operation B a decapsulation and re-encapsulation. If it's the latter one, then you need to change the source address to be one owned by B. That's basically the discussion about 8200 that's happening right now.
Two things here. The RFC 8200 says that destination options header, the option types that we are allowed to carry, allows to change the content, and it says that there are two flags in the options type, change flag. So the Bier option, the option type that we are proposing to carry Bier options, we say that we set the change flag to say 1, so that it's the routers understand that it's allowed to change the content of the beer options, wherein the beer header is encoded.
Well, I think
So-
that's basically something for review by Sixman, how to interpret that. But because what that doesn't say is whether or not the operation means that B becomes the source of the packet then. Right? And if B becomes the source of the packet, then of course it has to own a source address owned by B.
Right. But what do we think here is that the source address is not going to change. I mean, like,
Then you
I
just
understand
make it
that you
sub-
would like to do that, and I'm saying, if you come out of Sixman and get an overwhelming, sense that yes, this will be allowed, then it's fine. Otherwise, basically, the cost of doing business will be higher because you need to update the source address hop by hop.
Rajiv Asari, Cisco. So 8200 actually allows for the source IP address to be retained as the packet transits through the network. In fact, early this morning in the IPPM, we had a similar proposal in which the IOM data goes through the changes hop by hop. The source IP address does not change. But it's still worth checking to Torla's point.
okay.
You said that you use a multicast address in the IPv6 header. How does it work on the LAN?
How does it work?
On LAN, LAN.
Okay. I mean, like for L2, not had a good thought about that. But yes, but we are thinking that, it's just a way to, a couple of advantages here to use a multicast address in this type of network is that we can avoid changing the destination address of each hops. And again, it's a well-known address. To give you an example, it's just like how OSPF have reserved a multicast address to forward the packets, something like that.
Jeffrey, they could basically send it to everyone picks it up, and if they try to replicate, they don't find the bits to replicate to, and they just black hole the stuff. And that will work for.
Everyone could replicate
Yeah.
duplications.
Yeah.
Yeah, it's ugly.
Right. And then if you use unicast, the beer prefix, do you need a tunnel header? Because if you just use the unicast address, the beer prefix without tunnel head, that would it be possible for you to send the packet to the control plane?
You're talking about using unicast address as a destination address.
Right now you're using unicast destinations, and would the router somehow send the packets into your control plane? Because for example, it's your loopback address, right?
Yeah, I have the unicast cases, separate slide. We'll discuss that. I'll try to see that if I can answer that. Otherwise we'll get back to this.
Hi, Cisco. So it probably has to be a well-known linked local address, right? Because IGP snooping would kill this.
Mm-hmm.
Like I said, Bier in 6 authorship is wide open.
IGP snooping wouldn't apply to non-IP multicast MAC addresses. So if it's simply outside of that range, then it would just be flooded, not be subject to IGP snooping. So maybe that's the easiest way. No, I forgot my question. We don't have a procedure right now for Bier on a LAN, right? So basically having a multicast destination address, if you have 3 routers on a LAN or so, would be still to be defined, right?
Yeah, we will. Next slide. Yeah, I have mentioned that we will be using. It's possible to use unicast destination addresses for special cases. So this is one such special case wherein to support non-Bier capable nodes in the network, we can just tunnel over. Try to tunnel. I use the word tunnel, but it's not exactly tunnel. We can bypass the non-Bier capable nodes by using the unicast destination addresses. As you can see here that, let's assume that E is not Bier v6 capable. In this case, we can just, place the next hops, unicast address here. So in this case, what happens is it's not really a tunnel. What is going to do is, it's just to forward the packet by native IPv6 forwarding. And this is, and you can see that, we can avoid some of the complexities that we have talked about in terms of MTU, to add tunnels.
Gentlemen, resist the urge, okay, to build those shortcuts. We have an architecture which is a hop by hop. We have extensive tunneling, we have SR, we have all the stuff in place. So don't shortcut around. The quick and dirty hacks will remain dirty much longer than they have been quick. Okay, just as input. But we can discuss it out.
Yeah, we'll discuss. Yeah. I'll skip this. Skip this. Next. So, why do we think this encapsulation, may work? Some of the points that we'll discuss further. Why use IPv6 destination options header? Like I mentioned before, 8200 says that it doesn't really recommend adding new extensions header unless we don't find any suitable one to carry stuff that we need. And we think that destination options header fits the bill because we think that it's suitable wherein we have to bypass stuff where transit nodes don't want to don't support its better handling and backward compatibility. Why use multicast address as IPv6 DA for general case? Yes, again, like I said, like it's to make it simple, it's just like how the other routing protocols reserve on a multicast address, just to recognize that this is a Bier packet and to also to pilot the hop by hop forwarding. This can simplify things further. We can discuss anyways. This is another point wherein we this is one of the slides that we have skipped. We think that we can continue to use the IPv6 next header field rather than the proto field in the Bier header, because we think that it's better for backward compatibility, wherein many offline tools can be able to directly recognize the Bier header field. I mean, next header field in the IPv6 header. Yeah, in the previous IETF meeting as well, I think we have discussed about, there are comments about Bier ETH is clear. I mean, like, we can use Bier ETH to, for forwarding the packets in the IPv6 network as well. So we have tried to compare some of the aspects of, Bier v6 cap that we have proposed here with Bier ETH. The first stuff we have, I like to point out where it's not present here is that Bier ETH is not L2 agnostic, can work only with Ethernet links, wherein this is purely, I mean, basically since we are putting the Bier header in the L3, it's basically L2 agnostic. Hop by hop replication, yes, I mean, like, not sure if this is a great advantage, but we don't need to change the MAC addresses of each hop, destination MAC addresses of each hop, if we use multicast IPv6 address as destination. And we feel that this encapsulation has some advantages in terms of how to support non-Bier capable nodes, as we have seen that it doesn't really require tunneling. We can make use of the native IPv6 forwarding, where the transit nodes can forward the packet just by using the IPv6 destination address, unicast IPv6 destination address. And yes, I mean, like, Mike mentioned that about, by using the IPv6 header natively, we can try to see that we can get some of the advantage of network programmability here as well. I think in the next slides, we can, that Jingrang is going to present, that we can see more about that. I'll just, have a short mention about that here, that, for example, SRv6 introduced the networking programmability.
We have 4 minutes. And we have one more presentation. Right. Okay. Mike was saying, Dr. Gus, let's work on the problem statement, right? Let's get that one going, and then we can pick up pieces. Quick question, we got to move on.
Okay, on these slides, there's 3 Bier using multicast address that we talked about, that it doesn't work on LAN, so you have to use unicast, and that difference is gone. And the multi-hop replication, what you're doing is no different from tunneling. And in fact, you are making that, you are doing the tunneling
even on the hop-by-hop between the direct peers.
Well, actually, I think it's, hop by hop, end-to-end delivery, and then there's a new packet. So it would be lovely to have this presented at 6men just to get feedback. And then also you mentioned the draft that you once had, Bier in 6 or something? Is this sufficiently similar? Should that be merged or what?
All right, let's keep it short. So I'm highly sympathetic to not modifying the source destination, right? I mean, that would speed up the forwarding. Excellent. If the 6-in-man let it pass, cool. I think the option, keeping in the option is overwrote. I think that getting just the next protocol header, getting a specialized thing and just stick a Bier frame in that would be far more practical. But that's kind of how I see it. So it's kind of similar. We can merge whatever discuss it, shades of things. No, everybody's asking for a break. This is Bier. We are tough, okay?
Hello, everyone. This draft presents the BRV6 MVPN. This is the initial idea to define the BRV6 MVPN procedures and messages. It invents nothing but reuse the BRPTA attribute with the MPS label settle 0. And it reuses the BGP prefix SID attribute with the IPv6 address to identify an MVPN. The segmented MVPN and the extralated MVPN is not covered. This draft also helps understand the BRV6 and its applicability. It provides an option to support multicast service in non-MPLS IPv6 network using the BRV6 encapsulation. This one, just to say, IPv6 source address unchanged is used to identify a VPN. The local and the funct part represent the context and the upstream assigned VPN label used in BMVPN. The PTA attribute is reused. Just set the MPLS label to 0 because in the MVPN BRV6 encapsulation, it doesn't use the MPLS anymore. And we reuse the BGP prefix SID attribute. This attribute includes an IPv6 address to identify an MVPN. There is also some IPv6 infrastructure related. Sorry, please. Next one. Yes. There is some IPv6 infrastructure related files, like the originating router's IP address, route targets, extended community, and so on. These are all defined in the current RFC, and also GTM using BRV6. Next slide. Yeah, this is also defined in current RFC. So this is the references. Nothing is invented, and the BRV6 MVPN, the main point in BRV6 MVPN is to use the IPv6 source address to identify an MVPN. So the VPN label is removed, and the current messages defined already can be reused. That's what just presented this to seek for feedback.
All right, questions? Questions, Mike? All right, so I'd say this, continue to work on it with feedback, but in terms of adoption, let's again go back to the problem statement, and then we'll tackle it from there. That was great stuff. Thank you very much. Thanks everybody in the room. Minutes, please email them to me, gjchef@gmail. Send it to chairs. I think it's Mbone Chairs works too at IETF, but you should have my direct. Blue sheets. Everyone sign a blue sheet? Okay. Everyone find enough beer yet this week? There's plenty of beer around. If you need recommendations, just fire them out. You guys have a great week. Thank you very much. Enjoy Prague and the rain.